بسم الله الرحمن الرحيم. أبنائي وبناتي طلاب الصف الأول الثانوي، بنكمل مع بعض حل أسئلة كتاب المعاصر شابتر 2 يونت 2. سؤال 46 page 219. The opposite graph represents the relation between the square of the velocity v square and the displacement v square and the displacement for two bodies A and B that start their motion from rest, so both V initial equals 0. So the ratio between the final velocities of A and B, VA over VB after 5 seconds. Let's solve it together. What do we have? We have the relation between V square and D. You know well that V final square equal V initial square plus 2AD. But V initial equals 0 for both objects. So V final square equal 2AD. From the graph you notice that V final square directly proportional with D. So the slope for the graph is 2A. Let's get the slope for object A equals 4 minus 0 over 1 minus 0. So 4 meter per second, the slope 4 meter per second square, right? Or 4, make it 4 now, okay? What do we have? 2A, the slope 2A equal 4, means A equal 2 meter per second square. Okay, guys? And here you can write the unit, it's okay, meter per second square, because the velocity meter square per second square over the distance by meter, so it gives you this unit. It's okay, the unit of acceleration. Okay, guys? Let's get the slope for object B. So let's call it A for object A. Slope B equals 1 minus 0 over 2 minus 0, means a half, right? And this slope, as we said, equal 2A, so 2A equal half, so A equal 1 over 4 or 0.25 meter per second square, right? This acceleration for object B. So we got the acceleration for A and the acceleration for B. So now you can get the final velocity after 5 seconds for both. V final A equal V initial equals 0 for both, plus A for object A, T. A for object A equals 2, and he gives you the time 5, right? 5 seconds. So it equals 10 meter per second. V final for B equal AB times T, 0.25 times 5 equals 1.25 meter per second. Let's get VA over VB equals 10 over 1.25, means 8 over 1. So the ratio between the final velocity for object A and final velocity for object B, 8 over 1. The answer is here. I hope it is easy for you. Let's go to the next 47. A runner traverses a straight race track of length 100 meters in 17 seconds, where he moves the first 3 seconds with a uniform acceleration A, a distance D, reaches a velocity V. So V final, we call it V. Covering this distance, and he continues the rest of the race by this velocity. So the first 3 seconds moving with uniform acceleration, the rest means 14 seconds from the 17. Move by velocity v. So which of the following choices is correct for A and G? Let's solve it together. So the total distance equal 100 meter and the total time equals 17 seconds. Let's speak about the first 3 seconds. First 3 seconds from 0 to t equal 3. What do we have? We have V final, we call it V, equals V initial. He started its motion from rest, so 0 plus AT. A times T equals 3. So V equals 3A. This is the first thing we got. Okay? So let's speak about the distance D1 it covers, or he covers. D1 equal V initial T equals 0 plus half A times T square. T square, 3 square, right? So 9 over 2, 4.5 A. This is the first distance. About the second distance, D2, he moves with uniform velocity. So VT, V is the same, V equals 3A, right? From this relation. Times T, the rest of time equal 14. So 3 times 14 equal 42A. So this is the first distance and second distance. Let's get the total distance. He said the total distance 100. So 100 equals 3A plus 42A means 32 plus 3, 42 plus 3, 45A, right? Sorry, for the first distance, it's not 3A. First distance, it is 4.5A plus 42A means 46.5A. So hold on here, the acceleration will equal divide by 46.5, so 100 over 46.5 means it equals 2 point something, 2.15 meter per second square. Sorry. What we need? We need the distance he covered in the first 3 seconds, because he said that the D here, the distance he moved in the first 3 seconds. Right, guys? So what we have? We have D1, the first distance, equal 4.5A. So D1 equals 4.5 times 2.15, approximately equal 9.677, means 78 meter. So we calculated the distance he covers in the first 3 seconds, and also we calculated the acceleration for the first 3 seconds, because the second case, or the second part of motion, he was moving with uniform velocity. Okay, and also we can get D2 if he needs to get D2, the rest of the distance. Just subtract this number from the 100 meter if he asked to calculate the second distance. Okay, guys, let's move to next. And before we move to the next, this is the right answer, letter D. Okay, guys. Type. If here is say, if the displacement D covered by a body running a time interval T is given by the relation, it gives you the relation. Where A is the acceleration of the body, mention the conditions that make the previous relation applicable for the motion of a body. Type. we use this relation. Hold on, I want you to notice that D equal V initial T plus half AT square. This is the law that we know, right? Here, he gives you D equals half AT square. So V initial equals 0. So the first condition, the object starts its motion from rest, right? Second condition, the object moves in a straight line. Third condition, as you see here, we have acceleration, so the object has a uniform acceleration. This is a condition that we can speak about when we use this relation. Okay, guys? Let's move to the next question. The opposite figure represents the graph of velocity versus time for two objects A and B that started their motion from rest, as you see. In a straight line, which object has moved with greater acceleration? You know, to get the acceleration, we need to get the slope between velocity and time. So let's solve the first one here. The one that has large slope has greater acceleration. So slope A means acceleration of A. Slope A means V node over minus 0, V node minus 0 over 2T node minus 0. 2T node minus 0 means V node over 2T node. Let's get slope of B. Slope of B equals 2V node minus 0 over T node minus 0. So it equals 2V node over T node. As you see, slope B larger than slope A. So which object has moved with greater acceleration? Object B. Object B. Because as you see, it is sharper, right? Type. Let's go to next. Which object has covered a greater distance? You and Y. You can use the law to know which has greater distance. The law, you know that D equals V initial T plus half AT square. Okay, and apply. This is equal 0. You can get D for A and D for B. Or also you can get the area under each graph. Let's calculate it using the area. The area to get the displacement for A, the area of A equals half the base 2T naught times the height V naught. It equals 2V naught T naught. The distance for or displacement for B equal half times the base for B T naught times the height for B 2V naught. So it equals, hold on, here V naught only, V naught T naught, T 2 goes with 2, and also here. So V naught T naught. As you see, they have the same area. So this distance covered for A equals the distance covered for B. So as you see, both covered the same distance. Okay, and also for your knowledge we can use d for a, half times the acceleration of a as we got from while, the acceleration of a, v naught over t 2t naught, right, times t square. T square for a, t square for a, 2t naught square, right? And for b, half times the acceleration for b, 2v naught over t naught times the time for b, t naught square. So here 1/4 times v naught over t naught times 4t naught square. Here 1/2, 2 goes with 2, right? So v naught over t naught times t naught square. The first one, 4 goes with 4, t naught goes with the square, so v naught t naught. The second, t naught goes with the square, so v naught t naught. So they have equal distance. Okay guys, we finished page 219. Please subscribe، تابع وانشر القناة عشان تستفيدوا غيرك يستفيدوا، ونكمل شرح باقي المقطع. ربي يوفقكم انتم واولادي. كان معكم مستر ابراهيم سلطان، فيزيكس اند كيمستري.